All right, greetings everyone. So today we're going to go over some division and multiplication examples of recursion, and then we'll also um, look at what it would we will write them. We'll write up some methods or functions um, that don't use the multiplication or division operators. So essentially, imagine that you're working on a system that doesn't actually have multiplication or division. That used to be the case with some very primitive computers, is that they would not have a dedicated part in the processor for doing division or multiplication. And so maybe their language, a higher level language, has multiplication or division that runs on the system, but we're going to essentially rewrite the trickery that it's doing instead of having the dedicated division or multiplication. And then if we have time, we'll set up Eclipse. And then also if we have time, I have a really old project from over 3 years ago, written in Java, that runs launch pads, those little musical DJ set kind of things. And so I just want to open that up and look through it and understand the problems that can occur when you write code that's very old and maybe you don't remember any of it, and see if we can clean it up or make some sense of what's going on. So that's what I got planned for today. Okie dokie. So everything's good in Jeffland. I can SSH. His website's up, and hopefully you've all worked on, you've all finished assignment 6 and are pretty much all done on assignment 7. And let me know if you have any requests. Okay, so yeah, let's do division and multiplication without using the multiplication or division operator. Let's do this both recursively, and then we'll also do it in a loop, in a function, or a method. They're synonymous. Function and method are the same thing in Java. Because everything is inside of a class, so everything is a member function. Okay, so right, so let's grab the blank starter code. Do I have that? Okay, I don't. All right. Okay, so we are going to do MD, or actually DM, Dungeon Master. That's better, right? Okay. All right. Zoom this in a bit. And I don't know, how do I want to, actually, let's edit this slide so we can see the instructions better. So we can work on that and this at the same time. Okie dokie. All right, so we see here that we're going to have 4 methods. So let's just do the skeletons of those real quick and then make sure that we can compile. So we're going to have a division. We'll just call it div. We're going to have 2 divs. One will be with a loop and one will be recursively. Okay. And let's return doubles for both. And let's just make these public. Okay. And then these are going to take in two arguments, and we might think about their names. Maybe we say operand 1 and operand 2. We could say arg1 and arg2, or we can remember that when a programming class, right? Oops. Fat fingering my keyboard, sorry. So let's work on just making the skeletons, and that's always that's always a good first step. Make code that compiles, doesn't do anything useful, but at least it compiles. So you want to return something, and if you're really paranoid, you could make sure that it's definitely returning the same type. So there we go. So we've got our div_r and our div_l, and we might make a comment, right? We might make a Java doc, which I seem to not have just sitting here. Let's pull this up. Sorry, my text editor is not grabbing stuff. Okay. Okay, so we're going to stick the name here and then the parameters down here. So oops, sorry about that. Okay. All right. So definitely going to run out of space real quick. So if you recall, when we're reading the Java doc, the documentation online, everything that we're reading is coming from this comment block here. So it's really important that we populate this, that we put in details that matter and things that make sense. We never want to have documentation that's old and is not maintained. It's one of the worst things ever, is you open a project that has documentation, but that the documentation doesn't reflect at all what the code is. That's almost worse than having code without any documentation whatsoever. So it's really important that whatever you have in this documentation is accurate and that it's maintained. Whenever you make a change to it, maybe you change its behavior, which you shouldn't really be doing, but if you do change the behavior of your methods, then you need to update your documentation that goes along with it. Okay, so we're gonna say, oops, let me open a new tab so I'm not being super disruptive. Okay, sorry about that. Let's go back here. Okie dokie. So, so it's division I'm trying to remember how to spell. Okay, So this is going to be doing division recursively. Cool. And I mean, if there was more going on, we might explain what these are. But in this case, pretty much everyone understands what division is and what we would expect to get out of it. Okay, and then this is div L. Let's make this a little bit bigger. And this is going to be division via loop. Cool. Okie dokie. So at this point, let's make sure that our code compiles. All right, compiles must be good. And so let's just make sure that they work. So let's say system.out.println, and we're going to call divar, and let's give it 1, or 5, 1. Actually, 2. Why not? Okay, and then we're gonna call the other one, and we might use a printf if we want to label these, but right now I just want to see the 0, 0. Right. So because main is static, let's see. Let me recall what the best procedure is for this. We could make a class instance of DM, and then call the doubles of that, and or we could just make these static. Let me review how Jeff likes people to do it. Okay, so I just reviewed how Jeff wants you guys to do it. Looks like he just has you in contexts like this, that they're going to be that we're just going to make them static. Yeah, so let's do that. So we're actually going to change these to being private. Because right now these are only going to be used in the scope of this example. Nobody outside of our code is going to be running these methods. If it was the case that people are going to be running these methods, then we would have somebody creating one of these DM, a DM object, and then calling these methods in relation to that instance of this DM object. So that's what we're going to do here. We're just going to make things, or actually that's not what we're going to do here. We're going to instead make everything of static reference and make it private, so that only things inside of the class, like this main who is inside of this DM class, can access it. So we should be good. Okay. All right, so there's our 0, 0. Okay, let's write some code now. So we've got our division. So actually, do you want to make this doubles? Actually, I'm going to make these integers instead. The reason being is that computers run in integers, and it's going to make our code a bit simpler. So notice I changed the documentation and the code here. Okie dokie. And that's really important. You want to maintain the documentation as you go. Okay. So there's our refactor. We're now dealing with integers instead of doubles. So let's make sure that it compiles. Looks good. Okay. All right. Now let's write some code. So it's been a while. So let's write this guy. So we essentially are going to subtract. So because we don't have the division operator, we're going to subtract something, whatever the denominator is, and by whatever is in the numerator, and we're going to count the number of times that we're going to see that happening. And then in the case of the loop, we just count how many times the loop goes. So let's do that. Let's do the loop just to give you guys an understanding of what's going on. So we have our int, we're going to just call it result. We're going to assign it to 0, and we're going to say while and we can mutate these without without worrying, because we made a copy of what was passed to us. So we're not worrying about mucking up whatever main handed us. Just know that we can never go backwards. If we alter it, we can't go and fetch the original thing that was given to us. So in the sense of messing up what main gave us, that's perfectly fine, as long as we never intend on needing it again. So as long as this is greater than that, we're going to increment result. And actually, we might say we're equal to. We're going to increment result, and then we're going to decrement this by that. And then we're going to return result. Okay. So hopefully that's pretty clear. So this is with the loop. So we're going to pass in this divided by that. We're initially saying result is 0. So, and keep in mind we're doing integer division right now. So if this is bigger than that, then this while loop will never run, right? This will be false. If arg1 is bigger than arg0, then this loop will never run and will return 0. But if they're equal, so say this is 1 over 1, then these are going to be equal. We're going to increment result by 1. So result is now 1. And then we decrement. So now arg0 is 0. So we say, is 0 bigger than 1? It is not. And so we don't run the loop, and then we return 1. Okay, let's look at 2 over 1. So if this is 2 and this is 1, then we say, is 2 greater or equal to 1? Yes. Then we increment result, and then we decrement arg0 by 1. So now arg0 is 1. And then we go to run this loop again, and we say, is 1 greater than or equal to 1? It is. We increment result, so result is now 2. And then we decrement arg0 by 1, so it's now 0. And then we go to see if we run the loop again. We say, is 0 greater or equal to 1? It is not. And then we return 2. Cool. So there you go. So that's how you do division with a loop without using the division operator. And for systems, there are many systems out there that don't have hardware acceleration for division, or that maybe the elsewhere in the code, it's very, very heavy on division and needs to utilize other parts of the processor. People's code will do tricks like this, where they'll instead use the subtraction ALU of the processor. That's the arithmetic logical unit. Sorry. That's the part of the processor that's doing math, which, I mean, all of the processor does math, but that's doing like adding, subtracting, and multiplication and division sometimes. So the idea being is that maybe with some knowledge of your processor, you might do code like this, where you're optimizing for what's available in your processor. At the very high, fluffy level of Java, we really don't need to be concerned about that. But if you start working on very, very low level machines, that's definitely something that you should pay attention to, is what operators do you have. And in most cases, on the compilers for those embedded systems or whatever, they will write this for you. So the processor itself might not have division or multiplication, but when you're programming it, you are able to use the division and multiplication operators, because the compiler essentially is writing what we're writing here for you. Okay, and so let's comment this and while loop. All right, cool. Okay, so now let's write the recursive one. So this is really important for us to write a base case. And the base case that we should write should be when arg0, and keep in mind that we have not coded checks to make sure that arg1 is not 0. That would be an instance right here, or sorry, arg1. If arg1 was 0, this loop would never finish. So there are exceptions that we can throw. Right, Java has division by 0 exceptions. And so we can throw an arithmetic exception, and let's just take a look. Let's just say JShell. So if we say 1 divided by 0, we get this nice exception. Cool. So maybe we could do that, right? We know about exceptions. We've thrown that in our code. So if we say throw new, and that was a what, arithmetic exception. So should be able just to say this. And I think it takes, yeah, so it takes arguments. So let's just copy this argument. There we go. Okay, so now let's do that check. So if we say if arg1 is 0, there we go. Cool. Let's make sure it compiles. All right, compiles must be good. Okay. And if we needed to import it, this is where it would live. Cool. And we can even test to make sure that that works. So that's devel. So if we call devel make that 0. And there we go. We have our arithmetic exception, division by 0. Cool. And notice that we do get this, we do get the 2 that we would expect because we're passing 5 divided by 2. And if maybe we had a class that this belonged to and that had 2 parts, that had the result and then it had whatever was left over, we might like the equivalent of division and then doing the modulus, that whatever's left over in arg0 is at this point right here. At this point, whatever's left over in arg0 is the remainder. So maybe you might mention that. So right here, arg0 is the So if we needed to make modulus, if we needed to make a modulus method, then all we would do is that instead of returning result, we would just return arg0. Done. Like that's literally, our code could stay exactly the same. We would probably remove the result code because that's not necessary. But in the sense that if we wanted a really quick hack of making a modulus method, all we would change is right here. And if it was the case that we had some kind of object that could hold 2 things, 2 integers, for example, and it could be a class object that we had, we could pass both result and arg0 back inside. We could create a new object, put result and arg0 in it, and then now we have both the division and the result of the division and the remainder. So we should know how to do that. Okie dokie. And let's break that up. All right. Okay. Our method. We do it on time. Oof. Okay. definitely. I'm definitely gonna have to do the Eclipse stuff next session. Okay. So this one. So again, let's make sure that we don't divide by 0, because that's bad. Okay. All right. So now let's make our base case. And our base case is just going to be 0. Actually, our base case will be if they're not, if it's going to be essentially the inverse of this. If arg1 is greater than arg0, then we know if this is the case, then we should always return 0. Right? We're done. Otherwise, we're going to subtract them and then call ourselves. And so we're going to call ourselves divar. So this is the instant giveaway. Sorry about the noise in the background. So this is an instant giveaway right here. That we're dealing with recursion. Is that we're calling ourselves. And this might hurt our brains, but okay. So in this case, right, we're going to, let's say that this is 9 and this is 10. So 9 over 10 with integer division, we want 0. So we check, is 10 0? No, so we don't throw the exception. Is 10 greater than 9? Yes, it is, so we return 0. Cool, that looks good. Okay, now let's say 1 over 1. So is 1 0? No. Is 1 greater than 1? No. So we then say 1 plus, and then we call ourselves again. And so this is going to be 1 minus 1, so that's 0. So 0, comma 1 is the argument. So we've now recursed once. So we say, is arg1 0? No, arg1's 1. And then we say, is 1 greater than 0? Yes, it is, so we return 0. So this whole piece here is now 0. And so we say 1 plus 0. So let's make sure that the code is doing what we expect it to be doing. Maybe 6, maybe 10. And in this case, we should probably make these printfs just to make our lives easier. So we're going to make a format string. Okay, and then let's put, so it's what? It's that digit. I'm pretty rusty, so this might take another pass. Okay, so this we expect. Oh, and actually, let's put in our tests for other things. Oops. Okay, so let's do our division by. Actually, you know what? We'll save that for later. So we're gonna say 1, 2. So that's going to be 0. And then we're going to say 2, 2. And that we would expect to be 1. This we're going to expect to be 2. Oops, just realized I'm typing caps lock. There we go. And then this one, this is going to be 3. We're doing on time. Go. This will be 5. And then this will be 2. All right. So let's make sure that that works. All right. Oh, whoops. We need to actually update the... So right now, we're not properly recursing, because notice how we're only returning 1. So I've done goofed right here. That we're not taking the result and accumulating it. So take a moment and think of how we are accumulating in the loop and how we're not accumulating here. Right now, we're only returning the number 1. Oops. And so what's happening here? So think about that for a moment. All right. Hopefully you've thought about that for a few seconds. So right now we need to add the case where they are equal. Right. That was being covered here by this while here. The issue is that when they're equal, we're recursing again. Right, we're doing the subtraction and then we're returning 0, which, let's see, if they're, yeah, so let's just do that. So if these are equal, we're going to return 1. Cool. So let's take a look at the change of behavior. And there we go. Oh, wait. What is, did I update the printouts? So the first part, if they're the same, we return 1. We pass in a 2. Oh. Oops. There we go. Okay. All right. There we go. That's much better. So yeah, always double check your arguments. So there we go. And we should be able to get rid of this guy. Let's do that. All right, there we go. Yeah. So in a lot of algorithms, you'll see where these are broken up even more. But in this case, we do an extra recursive call without this. This essentially saves us one recursive call if they happen to be equal. But there's a lot of times when this case is going to serve is going to be what's going to happen. Most of the time, this is going to be what's going to happen. But if they happen to be divisible by each other, then this guy will save us one recurse. The thing though is that it takes up memory because we have to make a copy of this method every single time we recurse. So it's a trade-off. If we have this line in, if I could spell, whatever. So it's a trade-off. If we are concerned about recursing too many times, and we know that the data that we're dealing with most of the time is going to be divisible by each other, then this line makes a lot of sense to have. So that's called Hoffman coding, where you're allowing the way that you're coding to be influenced based on the data that you know that you're going to get. But in general, this line here, if we leave it here, will make our code even less efficient. Right now, this code is terribly inefficient because we could just do division and call it good. But the idea being, this is a way of problem solving using recursion. And so in this case, with this commented out, this is the most generalized and will work pretty much all of the time. But if you find yourself where you just need to be able to maybe your stack or your heap are filling up because you're running out of memory or that you've recursed too deeply, maybe adding this will help you, maybe. But it could add other issues because now your methods are bigger because maybe you call this 1,000 times. Well, right now the code is only 3 lines, but if you add that in, that's 4 lines, and so 4 lines of 1,000 copies of that one extra line could also push you over the edge. So just something to be mindful about. So that's division. I didn't realize that it would take that much time. I'm sorry about that. So next session we'll handle multiplication. We'll blast through that much quicker, and then also we'll set up Eclipse and we'll take a look at some old code. So that's what I got, and I'll throw this example up on GitHub. All right, Kapla. Come on, stop recording.